Hello everyone, welcome back to Zeey. In this video, we will try to uncover an intriguing topic, the Quasar Galactic Extinction event. If you are new to the channel, hit the subscription button and ring the bell so you won't miss any update. One of the most eerie aspects of this universe are extinction events you don't know about beforehand. 66 million years ago, the dinosaurs, for example, were blissfully oblivious of what was to come. The day they were going about their daily routine of consuming plants and each other, their world abruptly changed, and the world became desolate and dark almost immediately. These altered conditions ensured their demise, as they must have frantically wandered the hellscape that the planet had become while witnessing the extinction of their food. Numerous instances throughout the history of life on Earth, great deaths have been brought about by means that the victims did not comprehend. A dinosaur had no concept of asteroids. As a technological civilization engaged in science, we like to believe we have a handle on this, and in fact we are just beginning to be able to detect and even deflect asteroids that would have otherwise caused extinctions on Earth comparable to those of the dinosaurs. There have also been theories about how other natural phenomena, such as a nearby gamma-ray explosion or supernova, could cause an extinction event and sterilize the Earth's surface. And there, not only we lack the technology to determine the exact date and time of its occurrence, but we also lack the technology necessary to prevent it. Fortunately, this does not appear to be on our agenda in the near future. The contemporary neighborhood of Earth is tranquil, a backwater in a spiral arm in the galaxy's outskirts. There are presently no supernova-prone stars close enough to Earth to pose a threat, nor do any gamma-ray burst sources appear to exist, though at least one extinction event in Earth's history may have been caused by one. In the distant future, if we get too close to a dangerous star, we may confront such a threat. The galaxy's stars are dynamic and constantly in motion, so the future remains uncertain. Solar orbital shields can be used to protect the Earth from gamma-ray bursts and similar events if we gain a sufficient understanding of astrophysics to predict when such an event will occur. This is not a guarantee, but it is an understanding we are actively gaining even at this early stage of the game. Another question that can be asked is whether there are any cataclysmic events in the universe that we do not know about or are not presently considering in terms of extinction. There is one of these that could cause the extinction of not only a portion of life on Earth, but a sustained extinction event lasting millions of years that could wipe out the majority of life in the Milky Way. It may even provide a solution to the Fermi paradox. It is the theory that galaxies could be catastrophically steriled by their nuclei. Now this one may once again be avoidable through the use of advanced technology. As the quasar rages, a shield would need to be maintained for at least 100 million to more than a billion years. Either you maintain the shield or you perish and no longer maintain the shield. In such a galaxy, only the subsurface microorganisms of any planets with surface life that lacks technology would likely survive. It would be the return of life on Earth to its original form, the anaerobic microorganisms. A quasar, one of the most cataclysmic phenomena in the universe, is responsible for all of this. In addition, they are one of the most mysterious astronomical phenomena we are aware of because we do not fully comprehend how they occur or whether they could occur again. Quasars are active galactic nuclei, but they are not the only species. Therefore, all quasars are active galactic cores, but not all active galactic cores are quasars. Scientists believe that supermassive black holes at the nuclei of most galaxies are the cause of these objects. Massive amounts of dust and gas falling into the black hole cause its accretion disk and surroundings to go into radiation output overload, resulting in an extremely luminous galactic core radiating strongly at most frequencies of the electromagnetic spectrum. However, this material becomes mute upon passing the event horizon of the black hole. Even though it is the center of a hazardous storm, the eye of a hurricane is frequently quite calm. Here the black hole is comparable to the eye of a quasar's tempest. Even though one of the most intense environments imaginable is occurring just outside of it, its interior remains an enigma, and the black hole ultimately does not care. It simply accumulates matter at whatever rate it falls in. This environment, however, requires extremely dense quantities of material for the black hole to consume, which early galaxies tend to deplete, so the majority of quasars we observe are not only distant in space, but also distant in time. The most recent one we are aware of occurred roughly 600 million years ago, as it took that long for the light to travel through the interstellar medium to reach us. We do not observe any nearby quasars in our neighborhood of galaxies. The absence of nearby quasars suggests that they are more of a phenomenon of the early universe than something that can occur today. However, this might not be the case. In the majority of galaxies, the necessary amount of dust and gas for a quasar has already vanished, but there is still an abundance. We don't actually know that quasars become impossible, because nothing prevents the conditions that create a quasar from occurring again. In theory, a Kardashev Type 3 civilization could create an artificial quasar if it gathered and moved enough material, allowing for an almost unrivaled burst of energy. However, this raises the question of whether quasars can be reactivated. The Milky Way may or may not have been a quasar in the past. This is unknown. One possibility, however, is that this galaxy has never hosted a black hole and has never experienced this phase. This is fortunate because, if it had, the massive quantity of broadband radiation emanating from the galactic core could have annihilated any life forming in the galaxy. However, it is also possible that this galaxy has not yet entered the quasar phase. Gas and dust are all that's needed to create a quasar, and that's precisely what will occur when the Milky Way and Andromeda collide. It is important to remember that both the Milky Way and Andromeda contain supermassive black holes that will collide and merge when the two galaxies collide. The interaction between the two galaxies' halos has already begun. The subsequent merger of the two galaxies' remaining gas and material will create the potential for a quasar to ignite much later than the conditions of the early universe. Both nearby and distant quasars are frightening. For the quantity of energy produced, they are the most powerful events in the universe, however they are relatively small. All of this energy is condensed into a space that is only slightly larger than the solar system. The power of 1 trillion suns concentrated into a limited region. There are even quasar ghosts, where the cataclysm occurred, but then stopped, leaving behind an unearthly green emission from excited atoms that reveals the violent recent history of the host galaxy. However, recent observations have expanded on this. Observing 48 quasar galaxies and comparing them to a group of 100 non-quasar galaxies revealed that galactic collisions are indeed responsible for the formation of some quasars. Massive quantities of gas and dust gravitate towards the supermassive black holes at the center of the quasars when their distorted structures indicate a galactic collision. This can cause a surge of star formation, but it can also drive out remaining gas and dust, causing a galaxy to become extinct and star formation to decline. It comes out that distant quasars are 3 times more likely than not to interact with other galaxies. Since quasars tend to occur earlier in the universe's history, they presumably did not pose a threat to life because they eventually shut down before the galaxy is sufficiently populated with heavy elements from supernovae, although the outcome of this scenario is uncertain. A late quasar, however, is extremely hazardous. If a galaxy contains life but no civilizations capable of mitigating the radiation with a billion-year shield, the quasar would essentially sterilize the galaxy. At the time of the Andromeda collision, the Sun will be a red giant and have completely consumed the Earth, or it will be scorching the planet into a cinder world. But life everywhere else that cannot construct a massive shelter is in jeopardy. This is exacerbated if we are genuinely at the beginning of the game in this galaxy, where life typically takes much longer to develop than it did on Earth. By the time of the quasar, the galaxy could be burgeoning with life on innumerable worlds, whereas right now, it may not be. The quasar may not affect ice shell worlds with subsurface oceans or microbial life existing beneath exoplanet crusts protected by natural shielding, but surface life is unlikely to withstand the quasar's sustained, long-term effects. Nonetheless, a peculiar scenario is imaginable. Predictable galactic collisions take billions of years to play out. Once you have astronomy, you can determine whether something will occur or not. If you had a civilization in a galaxy, one reason to colonize the entire galaxy would be to prevent all life from becoming extinct. To preserve life in the Milky Way, you search for other life-bearing worlds to save, establish a minimal presence there, and construct a shield to defend that world from the rage of the galactic core. Because they value life, this is a shepherd civilization that seeks to archive and preserve biodiversity in the galaxy. They might prevent the Armageddon of any species they encounter. This type of civilization would be comparable to a Kardashev Type 3 civilization, but wouldn't behave like one despite spanning the entire galaxy, as transits from active galactic nucleus shades wouldn't be detectable at intergalactic scales. The irony is that such a civilization would not be attempting to utilize the most potent energy source available to them, but rather would be attempting to avoid it out of a tremendous fear of energy. Imagine a situation 4.5 billion years in the future. The Great Andromeda Milky Way collision is unfolding before us in the night sky of an exoplanet that we have relocated to because Earth has been destroyed. By that time, we will be a genuinely ancient species, and barring resets and extinction events, including those at our own hands, we might choose to head out and search the clement worlds of the Milky Way, and for that matter Andromeda, for signs of life. Then we could construct star coverings and preserve them in order to preserve the chorus of life in both galaxies. Or if we perish or transform into something else, someone else may construct a star silhouette for us, the former life of the planet formerly known as Earth, which the universe has forgotten existed. Alright guys, this video ends here. Thank you for your time. Subscribe to the channel for regular, in-depth explorations of the fascinating, strange, and unknown aspects of the universe in which we reside.